Hey everybody, it's Jeff here. CS161, we're in Module 7 this week, which is our first of two sessions. We're going to learn about loops. And if you look here, loops part 1 here is chapter 6. So now our module number doesn't match our chapter number anymore because we had the midterm last week, right? So just an FYI on that. But we'll kind of do our same thing as we normally do here. I have some code we're going to walk through. And as always, I would recommend you do these things side by side with me. You pause the video, you type the code in. If you just kind of watch this passively, you're not going to, you won't retain nearly as much than if you do this. You do it on the fly. There's some muscle memory involved here, but just like any language, you got to practice, right? And conceptually, if you watch the video passively while you're doing something else, you're gonna concept-wise you might be okay, but then when you try to code, you're gonna be stuck. So I can't emphasize enough how important it is to just do this side by side. Take the time and just do it side by side. So we're gonna talk about what a loop is, right? In a nutshell, a loop is one or more lines of code that will get run multiple times. And so, for example, if I wanted to ask for 3 numbers and calculate the average, the way that you know how to do this right now is you say input number 1, input the number 2, second number, input the third number into 3 variables. You add the 3 variables and you divide by 3 to get the average. So if you want to change that from 3 to 7, then you got to change the code. And if I ask you to change it from 7 to 1 million, you're going to be copying and pasting forever and you'll never get done. And so the key thing about a loop is that you're not duplicating the code, and the code will run for however many times it needs to run, right? And so sometimes that may be a set number of times. These are called iterations, right? Each time the code runs. Sometimes the loop will run a variable number of times based on the data. Even a loop could run just 1 time or even 0 times. So the whole point is that this thing is flexible here. And so some examples, just to kind of conceptualize some of the examples, some of these we'll actually do as well, or we'll do things very close to this. Enter numbers until the user enters 0, adding them together. We'll show you that one soon. Input buy and sell quantities, keeping track of inventory on hand. Use a mathematical convergence to zero in on a value. We'll play guess the number here in the later part of this video, which is an example of number 3. Allow the user to enter a name, searching a list to provide some info, and do it again and again until the user quits. These are examples of loops that we're gonna run. Okay, so let's start. SpaceX is in the news right now, so let's do a countdown. Okay, let's run this guy, see what it does, and then we'll explain it. All right, so what we saw here is we see t minus 10 seconds, 9, 8, all the way down to 0. Okay, and so the loop is these 4 lines of code. The loop constructor, the loop statement is what is this while statement. So the while statement is one of several ways to do loops. It is the most general purpose, and we call these while loops. And if you took CS 160, you'd learn while loops in Python. So it's a common method. So you got this indicates we're going to do a loop. The code that's between the brackets or the braces is what's called the body of the loop. And then this here after the while is the condition that will determine whether we stay in the loop or not. So we set a is equal to 10 and we print our starting message. And then we're going to say while a is greater than or equal to 0, we're going to run these 2 lines of code. So a is 10. So we go into line 28, we print t minus 10 seconds. Then we say a is equal to a minus 1, and so now a is 9. We come back up to line 27, 9 is still greater than 0. So we print t minus 9 seconds, and a goes from 9 to 8. And we keep doing that until we get to 0. 0 is still greater than or equal to 0. So we print t minus 0 seconds. And then we go a is equal to 0 minus 1, which is equal to negative 1. Now negative 1 is not greater than or equal to 0. So we exit the loop and come to line 31 and we print this statement here. So if I wanted to remove this last line, I can change the 0 to 1, or I can change that to a greater than. Either way it'll work. If I want to change my starting number, I can, and so on. This is a very basic loop. Okay, so now let's do this example number 1 here. And this is a basic loop that asks for input and processes it until the input until the right input value is entered to exit the loop. So in this case, we are going to ask the user to enter a value, and when they're done, they'll enter 0 as their value. Okay, and so we're going to say while that value is not 0, we're going to add it to the total, and then we are going to ask the user to do it again. And oh, if I have my C out backwards. Okay, so let's give that a try. I am going to change that to 0 so we don't have as much output there. Okay, so we're going to enter 1, 2, 4, 0, and I get my total of 7. If I enter 0 right away, I get a total of 0. Now, if you look at this loop, I have 2 lines of code that are before the loop, and 2 lines of code that are in the loop that are the same. Okay, if I wanted to instead, I'm going to copy this code, and I'm going to show you another way to do this. If instead I got rid of these and I did this, the problem is I have to set a to a value to prevent the loop from exiting right away. So let's try this. Let me set a to 0 here, and let's see what happens. And I'm going to delete Actually, I'm just going to delete all this so that we don't have to see all that same stuff. It's going to be in the file, right? You'll have the code. Okay, so in this case, because I set 8 equal to 0, the while loop immediately, it didn't run any time, right? And so if I set this to an initial value of 99 in this case, let's see what happens here. So now it asks me, and I type 1, I type 2, I type 3, and I type 0, and I get my total is equal to 6. This 99 is a throwaway value. And it's simply there to force the loop to happen one time. And so you have different ways to implement the exact same code. You can, getting input before and inside, or you can change it to ask for the input just inside with the right setup here. Okay? And so there's another way that I like to do it as well, right? And so I might instead create what I call a flag, and I'm going to call that loop active. Let's run this guy and see if I get the same results. Five, 10, 100, 0. Total's 115. So in this case, what I did is I created a Boolean variable called loop active, and I set it equal to true. And I said while loop active is true. So remember, I don't need to say loop active. I don't need to do this because I can't spell, because loop active is a Boolean value itself. I don't need to compare it to true. I just need to check its value. This will evaluate to true, and that is enough, right? Okay, so again, same results here. And you will, I would say you'll figure out your preferences over time, whether you like to use fake values to enter the loop, or flags, or ask for information first. And it'll also depend on what you're actually trying to do. Okay, you can also do this. So what I'm doing here is I'm saying while true, that loop will run forever, right? If I have code, and we'll demonstrate this in a second. A while true is basically saying I want to enter a loop that I have no way to, I don't have a condition to tell me when to exit the loop. And so I have to use a break command somewhere in my code to exit the loop. So if I do this, and I try to run this, I don't need a stupid error that says I'm not using the variable. My program is running. If you look, it's running, it's running, it's running. It's going to run forever. Because what I'm doing is I'm just adding 1 to total, and I'm just doing that over and over and over and over and over and over. And so if you find yourself inside an infinite loop like this, you click the stop button up here. Now I could, like if I did this, you'll see what it was actually doing here, right? See, it's running, and it's going to run forever. So be careful, right? An infinite loop is a common bug. You may have your condition wrong where you're not breaking in the right place. Your logic may be wrong, but this is definitely a way that you can build a loop. In our programs, we need to now make sure that when we're asking for user input from the user, we need to make sure that the input matches what we're asking for. So some of you did this in your earlier assignment where you basically said, no, that's not a valid number, and then you exited the program to make the person rerun the program, right? That's perfectly okay because you hadn't learned how to do this, right, yet. Okay, let's run this guy. So I'm going to basically run this code over and over and over until the condition is met. And when the condition is met, I break the loop, right? And again, this is using the break. Now, again, if I messed up here with my condition, I may never break the loop. Your common bugs is you break when you're not supposed to break, or you don't break when you're supposed to break. So you can add print statements, you can create intermediate variables to try to figure out how to do this. Okay, so let's recap this a little bit because I was very deliberate here. So we have loop continues based on a valid or invalid data. Loop uses a flag. Sometimes this is called a sentinel. And the word sentinel could also refer to a value as well, not just a flag. Or loop runs forever until a break statement. Everything I've showed you so far, you can build the loop in all those ways. Summing up the numbers, doing the input validation, all of those can be done the way we were doing. Okay. Your infinite loop is going to be one of your, so we talk about the biggest traps, right? Bugs. Infinite loop due to missing or incorrect expressions. Improper initialization. So the loop does not even start. Initialization, I think I spelled that right. Not processing the final value when exiting the loop. This is a common bug as well. If your break statement happens before you're supposed to add that number, for example. So, let's play guess the number. This is one of my favorite go-to programs. And we're gonna play it both directions, right? The first is we're going to have the human guess. Okay, so we'll create a variable called guess. We'll create a number of guesses variable, set that equal to 0. Okay, so the computer is going to say, I'm thinking of a number between 1 and 100. And we're going to create a variable called target number. And we're going to use the rand function to create a value between 1 and 100. So I think rand was mentioned. But let's take a look in the C++. C++.com is a great reference page. and it shows here the exact code that I'm using here. What RAND does is it's a built-in function that generates a number between 0 and this constant called RAND max, which is at least 32,000. I guess it depends on the library here. And so if I'm creating I can do the modulo here, right? This is not perfect, right? And I think studying random numbers in programming can be an entire class on itself, or master's thesis. And I've built hardware to generate random numbers that are truly random. For the purposes of this, it's fine. If you ran this statement, a million times and you did a probability or a distribution, you would find it wouldn't be perfect. Okay, so for any of you that ends up working on slot machines, for example, you'll have much more sophisticated methods to create random numbers. So I had a buddy I went to high school with who worked for Atlantic City Casinos, doing the hardware, actually, not the software. Okay. All right. Okay, so we will, inside the loop, we're going to get a guess. We're going to increment the number of guesses. This is a shortcut that is the same as this. This guy is called a post increment. And I know it's covered in the material earlier, but I don't know if I talked about it. So, but basically this is it's a shortcut to take this variable and increment it by 1. That's what the double plus is. But let's use that because it's more it's more obvious. If the guess is less than the target, then we say your guess is too low. Else, if the guess is greater than the target number, your guess is too high. Now I need to also break out of the loop here, because if I don't, it'll keep going, right? So let's try this, see if I got it. All right, so the computer has picked a number. All right, so I'm gonna guess 50. My guess is too low. I'll try 60. Still too low. Let me go to 80. Still too low. Now I guess is 80. So now I know my guess is between 81 and 89. Let's try 88. That's still too high. How about 84? And I got it. Okay, so very, very simple. The computer is just guiding me to converge on the number here. Okay, so let's do this in the other direction. Okay. Now I am going to hold ourselves honest by requiring we enter the number. Okay. And I'm going to create 2 variables, one called range low and one called range high. And I got my number of guesses, and I'm going to say while true, I'm going to, so the computer now is going to guess. And we start by setting the range between 1 and 100. And so I'm going to create a value. And the way I'm going to do that is I'm going to add to range low the midpoint between range high and range low, which is the difference of those two divided by 2. Okay, so this may not immediately make sense, but when we go through the program, when we run it, I'm hoping it will help. And maybe we'll run it again and we'll add some instrumentation to help you. Okay, and we'll say num guesses equal num guesses plus 1. And the computer says, my guess is, guess. Enter H if too high, L if too low, C if correct. Okay, so now each time the computer guesses, we got to tell the computer how the computer's doing, right? Okay, and so now we have a variable called feedback. If feedback equals H, that means the computer guessed too high. So what it's going to do, so let's say that, so range low was 1, range high is 100. Computer guessed 30 and that guess was too high. So now instead of guessing between 1 and 100, they want to guess between 1 and 30. So we're going to set range high equal to the guess value. Guess minus 1 actually, because we know that the maximum value would be 29 in this example. Else if feedback equals low, then we do the same thing on the other side. And then if they get it right, we'll break out of the loop. All right. Okay, I think, well, let's see. I did not declare the guess. I had target number declared in the previous example. Okay, so I got to pick a number. Okay, and if you look in the code, we store it in this variable target number, but the code doesn't use target number. So I'm going to say 71. That's the computer is going to try to find 71. And we can trust the computer here because I'm not using target number in the code here. So the computer guessed 50. That's too low. So now the computer's range changed from 1 to 100 to 51 to 100. And so the computer picked a number in the middle there. Okay, that's too high. 62 is too low. 68 is too low. 71 is correct. Guessed it in 5 guesses. Okay, so the computer is always going to get this, right? As long as we're honest in answering these questions, the computer is always going to get this. And my question to you is, do you know what the maximum number of guesses the computer will need in all cases, right? Between 1 and 100. No matter, we could run this with all 100 values. And the computer will do the same thing. Its first guess will always be 50. Its second guess will either be 75 or 25. The third guess will either be 12, 37, 62, or 88. It's, again, we're cutting in half each time, right? And so to really illustrate this, let's change this to a number between 1 and 1 million. And I'm going to pick a random number here. 23155. Okay, so he's too high. He's still too high. He's too low. Too low. Too low. Too high. Too low. Too low. Too high. Well, that's close. Too low. Too high. Too high. Oh wait, I didn't. Oops, I messed up. I had an extra character here. Let's start over. Let's start over. 23155. All right. Okay. So too high. Too high. Too low. Too low. Too low. Too high. Too low. Too low. Too high. Too low. High. 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 Low. Low. Oh, look at that. I didn't, totally random. I picked a number that forced the computer to zero in and guessed one number below and one number higher. And he got it, and he guessed it in 20 guesses. This is the worst case scenario, right? The worst case scenario is you guess the number right before the number and right after the number. 20 guesses. Okay. 2 to the 20 power is 1 million and change. Okay, so this is an example of, again, our power is a 2. I picked a number that was approximately equal to 2 to the 20th. So under the worst case scenario, the computer will take 20 guesses. I can change this code to now pick a number between 1 and 4 billion, and the computer will get it within 32 guesses. So you could play with this and have fun with it. You can't go to 4 billion if you're using ints though, right? You can only go to 2 billion. So unless you want to, use negative numbers or use the double longs, okay? And so good opportunity for me to throw in that trivia here about again when you're taking data and you're cutting it in half and then cutting it in half and so on. This is where your power of 2 that we've learned in previous classes can help us here. All right, let's keep going. There is another way to implement loops besides using the while function, and it's called the do loop, right? I almost always use a while loop. So the examples I've given you are the type of code that I use all the time. There is another option called a do while. Some languages call this do until. And so I think I used do until earlier, so I want to say that in case I do that here. So let's try something here. Int max equals 0. So this is a different syntax. Enter a number, 0 to quit. This is the same as we did before. If x is greater than max, max is equal to x. While it's not equal to 0. So let's run this guy, make sure I did it right. Okay, so it worked. I entered a few numbers and it gave me my maximum value. So let's see what's happening here. So when you do the do loop, it basically says you're going to run this code and you're going to run it over and over and over while this condition is true. There is a subtle difference here, is that you will always run this code one time. because Matt, you will always run this code one time because X has not been assigned until this statement. And so we'll run the code once. If I entered 0, and we can do that, right? We can just enter 0 right off the bat. And the code will correctly process here. So if you know that you're going to enter, if you know that you're going to run the loop at least one time for sure, you can do it in a do while statement, and it is a little bit more logical than one of the earlier methods that I showed you. Okay, and so let's talk about where the do while loop doesn't do what you think it might, where you think it might, does not behave how you think it might. And we'll do our countdown. Greater than or equal to 0, 0, and then we have liftoff. Okay, so if I run this code, I need to declare my variable. And I enter 10. My code works as expected, like my very first example. If I enter 0, though, I get t minus seconds and it says liftoff, so that worked as well. But if I enter a negative number, look what happens, all right? I get this t minus -1 seconds, which is probably not intentional. You could fix it, right? You could fix it by having another while loop that makes sure the number is positive. I mean, there's, that's what you'd have to do, obviously, to make sure you always need to be checking your input so that you don't create bugs that are of this nature here. Or you can modify it so that, you handle the error before, before running the loop one time. Okay. So we've done a number of examples here. We did some stuff like this. We did this with the guess the value. We haven't done strings yet. We will before the end of the video here. And we've done some other things that are kind of like that. Okay. The while loop is one of the key elements of programming. Hard to call it the most important because you got to do conditionals before you do whiles. So maybe conditionals are more important, right? But it's the way you get out of having to duplicate code and having to hard code the number of times things happen, right? It creates this flexibility here that allows programs to work how you want them to work. Okay, there is a simpler loop structure where you will just iterate across an index variable a set number of times. Okay, i.e. every value from A to B, for example. Okay, this is called a for loop. And I think the book calls it a count conditional loop, which I had never heard of before this textbook. Okay, in all previous classes, including CS160 and CS161, before we created CS161 A and B, we taught for loops before while loops. Same with all the classes I took. So this was strange to me in this book where we where we covered while loops, more while loops, do while, and then we get to for loops. So originally I was going to cover the for loop first, but I wanted to follow the book in case you're using the examples and going through them in order. Okay, so let's do some examples of the for loop, right? Let's run this guy. All right, so what the for loop does, got some different conventions you can use here, right? Whether you have spaces or not. We're basically saying I'm going to use an index variable called I. Could be any variable, right? But it's common to use variables like I and j and k and so on. So we're going to start at I equal to 0. We're going to run what's in the loop until while I is less than 10. And we're going to increment I by 1 each time. And so that's why you see 0, 1, 2, 3, all the way up to 9. We stop at 9 because our condition is we're going to keep doing it while I is less than 10. If we change that to an equal, we get the 10, we get the 11th entry, right? And the reason why I wanted to show that here is, again, the first time we ran this, let me run this again. We ran the body of the loop 10 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We ran it 10 times, but we went from 0 to 9. Remember, I emphasize this so much in CS 160. We tend to almost always start counting at 0. It's standard practice in programming and computer science in general. Okay, you could do this. You could do that. Nothing's stopping us. And the same, we go from 1 to 10. Okay, and there may be reasons to do that based on what you're trying to do here. Okay, and so this is a way of running this could be a variable, right? You can get how many times you want to run, and you enter that as a variable. But the point is that we very systematically go through each value of I from the starting point through the ending condition based on how we change the value I here. Okay, and it's very structured. Technically, we could change I within the loop. This will run, but it does break the rules, and I put that in quotes because it lets you do it, right? But it breaks the rules as it's defined for standard practice for for loops. So for example, we could take this code and we can say if I is equal to 3, let's change I to 8. So let's see what happens when I do that. So when I get I to 3, I print the note, then I change the value to 8, and the increment happens and makes it 9. This is terrible practice. Don't do this. If your loop index needs to change because you're doing things, use a while loop instead. This is one thing that I would say most programmers are consistent on. There's a lot of things that programmers will debate, and they'll be on their soapboxes saying, oh, you can do it this way, or this, my way's better, your way is bad. There's a lot of that stuff out there. But this is one area where most developers, most software engineers would say this is bad practice. In fact, I think the book, I think says the same thing. Let's see. Yeah, here we go. Common error, loop variable updated twice. So I put my I++ or plus I here, and then I do it here. Bad practice, right? Another bad practice. I have like a different, something unrelated to the index variable in here. That should be inside, right? Or I have two things that are happening, right? The for loop should be very, very structured. Okay, and if you fiddle with it too much, you want to use a while loop. Okay, so we talked about continuing this habit of staying from zero. Let's talk about, well, what else could we change in here, right? What about changing this to that? See what happens. So in this case, we're incrementing I by 2. And so this would be a way for you to check every even value, for example. That's perfectly okay. This is good, right? Another option is you can go backwards. So we can do our T minus here, and a for loop takes fewer lines of code, right? So if I go back, I'll find my countdown here. Let's compare them exactly. Okay, so let's run. We should get the same thing twice here. Oh, I don't have the... Okay, my cout statement is, I think, just do this instead. Let's make it the same to remove any confusion. Same output. 1098 all the way down to 0, 1098 all the way down to 0. If you look at the for loop, 1, 2, 3, 4, 5 lines of code. 1, 2, 3, 4, 5, 6, 7 lines of code. So again, when you have clear structure, the for loop is almost always going to be better. But if you needed to reset the countdown, like if this was a program and you would reset the countdown due to something else happening, the while loop clearly is the way to go. Anything you can do in a for loop can be done within a while loop. And so actually, let's capture that here. Anything you can do in a for loop can also be done in a while loop, but not necessarily in reverse. This is 6.10.3 is we're going to create a temperature conversion table. If you know your Celsius degrees, minus 10 is quite cold. Plus 40 is quite hot. And so we're going to start at minus 10. We're going to we're going to go up to 40, and we're going to go in increments of 5. So we're saying current C is equal to current C plus 5. Again, this is that shortcut method of doing that assignment here. So if you remember, and maybe you don't, but I always have to look it up as well. We take the Celsius, we multiply it by 9/5, and then we have to add 32. And you see I'm using 9.0 and 5.0 to force this multiplication to result in a float, so that when I divide by 5, I also have a float, and so on. I'm sorry, these dogs barking away. You may or may not be able to hear them. Okay, I'm not going to worry too much about formatting here. Let's see if this works. So minus 10 degrees Celsius is 14 Fahrenheit, 5 is 23, 0 is 32. Most of us know that one, right? 5 is 41, 10 is 50, and so on. 30 is 80. I always think of 30 as 85, so this is right. So this is basically showing us our temp conversion, Celsius to Fahrenheit, every 5-degree increment. Okay, you could do this as a while loop as well. Remember, we can ask the user, right, and say, what increment do you want to build the table? Let's try that. So maybe I don't want to do it every 5, I want to do it every 10, right? Or I want to do it every 1, right? And I get my full list, right? So this could be a variable, right? I can enter all 3 of these as 3 different variables. Tell me your lowest temperature, tell me your highest temperature, your highest temperature, tell me, what your step is. Do you want to go from Celsius to Fahrenheit or Fahrenheit to Celsius? And you do it the other way, right? It's a great program for you to practice on your own to get familiar with this stuff. Because your calculation is not that complicated, and you could focus on what's the user experience and what will the user want to do, and how do you make your program more and more general purpose. All right, I have one more thing I think we need to talk about, which is looping through general purpose input, not just like enter a number, right? So 6.3.1 in the book. Okay. Remember, when entering data from the console, you need to use Control-D to act as the end of file. So we haven't covered the cin command very much in previous, so we're going to kind of go through this in a little bit of detail here, and then we'll wrap up the lesson, I think. So let's create a total count. Okay, so we're going to use this cin peak to look. We're going to look at the next character, and as long as it's not the end of file character, I'm going to increment the total number of characters counted so far. I'm going to get that character and put it in the char variable called letter. If it's the letter A, I'm going to increment the number of A's I have found. Else, if it's the letter B, I'm going to increment the number of B's I found, else I am going to increment the number of others I found. And so now we're going to print out terrible variable names. It's like I have total count and then I have count A. I should be consistent, right? Okay, let's try this. So I hit Control D just there. So I hit return and I kept typing and then I hit Control D. So there's one B here, right? That's right here, right? There's 3 A's. There's one there. And there's 2 in the word always. And then if you count up everything, let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's another space right there, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Now, there is a return statement which makes 35, and maybe I miscounted. Let's try this one more time. Okay, I typed 26 characters, right? Because I did our alphabet here. But the reason I have 29 is because I hit return there, and I hit return there, and I hit return there. So the return key is a character. And if we go and we look in our ASCII table, you will see, and I think, is it 13? Oh, I'm correct. 13 is what's called a carriage return. And that's the fancy name for hitting enter. And for those of you that ever used a mechanical typewriter, that's where the word comes from, carriage return, or a word processor. So that's why I get 27 here. Now what we could do, we can say, we could, for example, in this count other, we can say if the value is not a carriage return, or if it's only a letter or a number, we count it. We can add to this, right? And make and we can ignore spaces. We can do that kind of stuff. We have that information in our ASCII table to be able to do that. All right, so let's take a quick look at the book here one more time. Okay, we just did this, right? We did some examples here. I had skipped that and realized that I had to come back and do that. I think we're probably pretty good at this point. At this point, you have a bunch of examples. You should go through the material in the book, of course. The more of these you do, the more it's going to stick. And then we have some statistics-based exercises here, the discussion, then of course the assignment. So as always, if you have questions, send them along, post them on the channel, the discussion board, or on the Discord. We're seeing just 2-3 questions a week on Discord between all of the CS161 classes. So not a lot of activity, but there's at least myself and 2 other instructors on there. So you'll get some good response if you do something on the Discord. And with that, we're good. Questions, let me know, and good luck with Module 7.